This is chapter 2 demo. So you might want to open it up on your end so you can follow along and we can do these 3 problems together. At any time, you may pause this video and then start it again, or kind of go back a few minutes if you need to hear something again. So when we open chapter 2 demo, you see this instructor tip show up. So this is specifically for LAMC students. It heads up not to use the help menu because they are using different technology, or for different schools, they might do it on a calculator, or they might do it by hand, which we're not going to be doing. Question number 1. An airline offers discounted flights from Atlanta to 5 American cities. Below is a frequency distribution of the number of tickets purchased for each location based on a random sample of purchased tickets. So the way this data was collected, or could have been collected, they go to a particular, let's say, ticket agency, and they collect data regarding how many flights were sold to Las Vegas, how many flights were sold to Orlando, New York, Chicago, and San Diego. And it was for a particular airline, let's say Southwest, and they were discounted tickets. That's what they're telling us. Okay. So now we want to kind of analyze this data. Which city had more, what was the trend, and so forth. So we're going to change the actual counts here to percentages, like of all the tickets sold here. What percent went to, let's say, New York, which seems to be the most popular in terms of how many tickets they were had sold. Okay, so for a relative frequency, we're going to change it to a percentage. Was that New York's 50%, 20% of the total? So let's open this in StatCrunch. And I'm going to share that window with you. Let me move that to the left so we can see the data here. So anytime you go to, we could get this information a couple of places, but they're most likely going to want a graph. So we're going to go to graph. And because this is categorical data, we're going to make a bar plot. It was categories of cities. Okay, so that wasn't like a measurement. But if it's something we're taking a measurement of, then it's a histogram. So bar plot. We have the summary. The data means like you have like the original. Sometimes you'll hear me refer to it the raw data. It's the original data that was collected, like the spreadsheets and where all the counts were accumulated. Here they just summarized it. Okay, Las Vegas had 1193 and so forth. You'll have different numbers. So that's why you want to do it with me, so you can do it for your data set. So with summary, because they summarized it for us. So the categories, because it's categorical, are under the column titled response. The cities, the categories of the cities are under the column response. And then the actual counts are in the column titled frequency. So if we do frequency, it'll give us these same values. We want to do relative frequency, which means we want it to change it to a proportion. If we want it as a percent, we can change it to a percent, but most of StatCrunch or my math lab questions want it as a relative frequency, the decimal version. Another thing you want to select is value above bar, because if you want to know the actual value, it'll be easier than try to estimate. And then there's more things options down here, but we don't need those at this point. Mainly it is if you want to make a nicer graph. So compute. Now, notice that this is Chicago's first and this is Las Vegas first. So let's see if we can make it in the same order. So go to options, edit, and the order by ascending. If we select worksheet, then it'll do it in the order that's on this StatCrunch table, which is what they're calling the worksheet. Okay, so now when I click compute, there's a, you could see that it's in order. Las Vegas is first, then Orlando, then New York, Chicago, and San Diego. It says round to 3 decimal places. We have to be careful here. These happen to be 3 decimal places, but it's always a good idea to kind of hover over near, let's say the 0.254 for mine, just to make sure that it was rounded correctly, because sometimes a StatCrunch rounds it to something slightly different. So this one is okay. This one is okay, just to 3 decimal places. Just always double check. Most of the time it'll be okay, but in a couple of problems it won't be, it'll be different. So you just have to be aware of that. So go ahead and put those values in. If you need to pause the video to do that, go ahead. And I'll check answer. Maybe in the future when I do this, occasionally I do a typo and you might get it wrong. So then you could go back and fix it and see if you did a typo, you did 2 decimal places. Sometimes I do that. If you get it all wrong, you could do, try another one. You could keep trying as many as you can until you get 100%. What proportion of the tickets were in New York? So now I can just look here. It's 0.312 or 0.312, either one. 3 decimal places, which I already have. So about 31% were New York, which was what I had said, which one was the most popular in terms of tickets sold. Construct a frequency bar graph. So this one's a relative frequency bar graph with the percentages here. This is with the actual counts. So it should be the same general shape. So I could see that it goes up with the first 3 and then it goes down with the last 2. So this one goes up 3, this one goes kind of curved. So the only one that goes up 3 is this one. But if you visually want to see that, you can just go to options, edit, and view frequency, compute. And then it changes this side scale to the original counts instead of the proportions. So we can see that the tallest one is near 1400. So if this is 1200 and that's 1600, middle is 1400, yes. Whereas here, New York is not close to 1400. Here, New York is close to 1400, but like the Orlando is like in the 500, and Orlando is not here in the 500. Click on final check. Continue. A lot of these problems are multiple steps. You have to be patient. They seem to never end. Construct a relative frequency, and that's the one that I had before. Now the shape's not going to change, or the distribution is not going to change. You're still going to have the same heights. So whatever you chose for the first one should be the same diagram for the second one, except over here, it's in C, or New York being the highest. And then like a staircase pattern for mine. So kind of match your diagram with what StatCrunch has. Continue. And now they want a pie chart. Now, again, we can kind of by default look at the data and choose the correct pie chart. Then I'll show you how to do it on StatCrunch. So for me, New York was the most popular. You just have to make sure, like in this case, New York is green. And over here, New York is green. So I want the one that has New York being the widest because that was the most popular. So that's this one here is the widest. This one is not the widest compared to other regions. This one looks almost the same as the red one, which is Orlando. So visual, and this one looks a little bit slightly larger than Orlando. Now, I see that these two here, the smallest two, are different from these two that maybe potentially might be the answer. So Chicago should be a little bit more wider than San Diego. So Chicago's the yellow. Yellow should be a little bit more wider than San Diego. But this one seems significantly more wider. So this kind of seems like it will be the diagram. So let's verify this. I'm going to close this one. If you ever need to go back to it, if you go here to StatCrunch, results hidden, it'll show you the one that I just kind of temporarily closed. I click on it, then I can go back this diagram again. So let me close it. So it doesn't actually close it, it's stored in here temporarily. Okay, so let's now do a pie chart graph. Pie chart. And again, we don't have the original data, we have the summarized version of that. Similarly, the categories were in the column titled response, the counts were in the column titled frequency. We could just leave the default settings. Starting at 0 just means like it starts horizontally, which it looks like most of them do. So we can compute. So it's kind of like a little bit turned, like New York happens to be green here. Sometimes the colors don't match. Like here, Las Vegas is in blue, whereas here Las Vegas is in red. So just be careful. But if you can kind of see, the green is a little bit bigger than the yellow. I mean, the Orlando and Las Vegas. So you have three that are kind of similar, which New York being a little bit wider. And then these seem kind of a little bit evenly spaced. Like these, where here it's a little bit too small. So yeah, that kind of confirms that that's the diagram that I want. And then continue. Excuse me. A local news broadcast reported that 6.8% of the tickets purchased from the airline are for flights with San Diego. So I have it over here, 6.85%. If you look at the value at the top, San Diego has 6. Here, see how it's rounding it to 6.8, where here they rounded it to 0.5. So this is actually to the nearest tenth would be 6.9. So it's a little bit rounding difference there. Well, for this sample, it's true that about 6.85% of the tickets came from San Diego. And now they're saying, what's wrong with the statement? Because the news reporter is saying that about 6.8% of the tickets purchased from the airline were to San Diego. Okay, so the percentage is incorrect. No, the percentage was correct. We just checked it. No level of confidence is provided along with the estimate, or there is nothing wrong with the statement. The issue with this is that the reporter is saying that all of the tickets were purchased that 6.8% of all tickets sold were to San Diego. But in the original problem, this was just based on a random sample of the purchased tickets. So they didn't count them all. They just took a sample of all the tickets that were sold just to get a rough estimate of, what percentage each city is selling. So because this is based on a sample, it's not like the absolute truth for all of the tickets, but it should be in the ballpark. So when we do surveys or samplings, usually we kind of give a little window and say, okay, it's about 6.8%, maybe give or take 2%, like what we think will be off by. So we call those level of confidence. It's like a little window, we should say, two values it's between to estimate like the actual number of sales. So if you look at news, when they're ever reporting, or even articles, when percentages or statistics are being reported, sometimes they'll say it verbally with a margin of error of 3% or 4%, which is the typical amount that's used. Or they show a graphic on the bottom of the little graphic that you'll see like plus or minus 3.03 for 3% or 3%, or MOE for margin of error. So we have to be careful when we conduct statistics. Next question. We do these statistics to approximate some value for the entire population based on that random or sample. So the best we can do is just what we call infer, say that most likely for the entire population, it will be between these two values, let's say. I'm going to close StatCrunch. Again, don't use the help menu. Let's click on this icon to view the table. And I'm going to go ahead and open it in StatCrunch. So we're going to need it. Once you open it in StatCrunch, we don't need this window anymore. The only thing I'm going to look at the title, viewing times in seconds, so I know what these values are representing. Okay, let me share that. It looks like it's not being shared since I closed it. Now if on your computer, you can have two windows up. You can I usually kind of like slide one window all the way to the left and let go, and then take the other window and slide it all the way to the right and let go, and then it'll take up the two screens. And then that way you could be looking at the two screens simultaneously. You have to go back and forth. An internet media and market research firm measured the amount of time an individual spends viewing a specific web page. The data in the accompanying table represent the amount of time in seconds a random sample of 40 surfers spent viewing a web page. So this market research was probably for a company that sells products to surfers. And maybe they want to see how popular this web page would be. Create a graphical summary, write a sentence that describes the data. So here's the seconds, which were the amount of time each person spent viewing the web page. So they recorded the time spent for 40 surfers. And here's the what we call the raw data, the original spreadsheet of the values. They didn't summarize it for us, like in the previous section. Okay, create a graphical summary. So just like what we did before, but now it's frequency on the vertical axis, which is the actual counts. So it's not relative frequency. It's not like the proportion of, what they were viewing. Now, in this case, we have what's called a bar graph. This data is not like categories like cities. This is actual measurements of time. So graph, instead of a bar plot, we're going to do a histogram because it's what we call quantitative data. They were measuring something. In this case, they were measuring time. It's not like a category to choose from. Okay, so we'll select column 1. We're going to keep it as frequency. We want the original counts, and we do want the value above the bar. It'll make it easier if they ask us anything about the actual counts. Compute. Now, notice here that the width of the bars are being labeled differently. Like this is 80, which means this one's 40, and then half of 40 is 20. It's going up by 20s, whereas here it's going up by 25s. So it's not necessarily going to match the same diagram. So, but we can change the width of these bins or these bars. So we're going to go to Options, Edit, And here's the bins, those bars that we want to change the width of it. So if I look here, it starts at 0. So it start at 0. And then we said that these are going up by 20. So we can say that the width is 20. So how I figured out the 20 was, if this was 80, then halfway must be 40. So this one's 40. And then this one must be 20. Half of 40 is 20. Thank you. Now, there's a way to change these here too. Like, I think at the x-axis, but you don't have to do that. It's above and beyond what we need to do. The thing is, I just want to look at the general shape. So it kind of goes down, and then there's like this little over here. So just match your shape. There's only one that's the same. Like this one doesn't look like what I have. So sometimes you'll have two that are very close. So you have to be really careful in not choosing the incorrect one. And I'll point that out when we get to it. Write a sentence that describes the data, choose the correct answer. So it seems like there was one potential extreme value here. Sometimes we call those outliers. That was kind of separate from the rest of the group, and it happens to be on the higher amount of time second, so to the right of this graph. So if I kind of trace it, I notice it kind of tails off towards the right. There's like a little tail here. So that tail, which is on the right side, was created because there's a potential outlier on the right side. So we say that that distribution is skewed to the right, wherever that outlier or that tail tends to drift off to. So if your tail is on the left-hand side, your outlier is on the left-hand side, then you would choose left skewed. The data in the accompanying table represents the ages of the presidents of a country on their first days in office. And they don't tell us which country, so it's very vague here, but some random country. Let me close this one. If you want to keep this open, you can just, and you don't need this anymore, you can go to you can go to StatCrunch, new data table, or sometimes here it's going to open it up yourself. But if you just need a clean table because you want to do something separate, you can click new data table, and then that'll give you a new table. Well, mine, I'm not going to share that with you, but that's how you would do that. Okay, so let's open this in StatCrunch. I'm going to close this one. For me, I have to close it because I have to share a new screen with you. Sometimes it's good to close it because then you have, you might have like 10 different screens open or tabs open. That's not good. See if I chose the right one. Okay, so, oops, I didn't choose the wrong. Right, let me close this one. Hold on a second. Try it again. And then it says president ages. So this is representing ages of presidents. They don't say which country, so but whichever country it is, that's 43 ages recorded. Construct a stem and leaf plot. So this is just another way we can summarize the data. So in conducting these analysis, the first thing we do is we decide on what the question is going to be, and then we collect the data. After we collect the data, we organize it in tables and charts and graphs. So that's what we're doing here, different ways of how do we organize first in graphs and charts, so then we can analyze if there's any trends, like, is it skewed? Does it have outliers? Where does the center appear to be, etc. So since this is a graph, you'll go to graph and scroll down to stem and leaf. Click on that. Select their column, which our ages were in column 1. This outlier trimming, change that to none. We don't want to trim or take out any values. To trim, it means like take the outliers if you just want to focus on the typical responses and you're not concerned about one unusual response doesn't represent the group. Like if there was one president that was like 18 for some reason, we might want to take that president out because that was like an unusual year or something happened. And we just want to know the general trend, not to include that outlier in our summary. But here, we're not going to trim anything. We might have to change the leaf unit, but for now, let's leave it. Let's compute and see if the StatCrunch gives us the correct leaf unit. If not, we'll go back and we'll change it just like the binning for the histogram. So notice here it's 2 for 4, 2 for 5, and 2 for 6, which looks like what it is here. So we're okay. So these numbers here, like this 4 with the 0 means there was a 40-year-old president. And then this 4 with the 4, it was a 44-year-old. And then a 45, 46, 47, 48, 49, 49. And then 50, 50 means that there was 2 presidents that were 50-year-olds. There was 4 presidents that were 51 and so forth. And then the oldest was 69. That was the last one. So instead of putting all the 40s in one row, they're dividing the 40s by 5. So they're going from 40 to 44, and then from 45 to 49, and then from 50 to 54 and so forth. So just pick the one that matches yours. Like for example, mine has 404 and that's these 3. And then you just have to be careful. So my last one is 579, which is between now B and C. And the difference is mine is in row column. So mine like starts with 51 and then goes to 50 in this graph here. And then this one is 50, 50, which mine is 50, 50. And first of all, this B would be an incorrect stem and leaf plot because you can't do 51 and then go back to 50. It should be in order from smallest to largest. So the 50-year-olds should be first and then the 51-year-olds. Continue. And now the shape. So for the shape, you kind of have to look on the side. So you're starting at the lowest number because the number line is like vertical instead of horizontal. And kind of pretend like you're turning this diagram on its side. So I could start here. And it looks pretty even. It looks like the peak is in the middle. And then it seems to like taper off. So that would be pretty symmetric, bell-shaped. Sometimes students do uniform. Uniform would be like all the heights or the lengths in this case would be the same. And these are not the same. Like these 2 are a lot larger than this 4. If you say it's uniform, you're saying that the height of the 40s to 44-year-olds are the same as the 50 to 54, which is obviously not. Now, if you've messed up and you want to do it to get, the full credit, you do similar question, click on similar question, and then it'll generate a new question and you can retry it as many times as you wish. Let me expand it. Well, let me close this window and expand it. So I'm just going to check, make sure I answered all the questions. And so it looks like everything is complete. So that concludes this demo.